Okay, hello everybody, and thanks for showing up. I am Michael Youngkin. I'll be your barista for today. If you couldn't tell by the apron, you certainly would by the man bun. I'm a member of Magic Wand Solutions. We're here to present JavaTime.online, our solution to finding the best time for coffee on campus. All of us work at the library, but let me introduce the team. Michael Youngkin, Head of Web Services. Adam Truzinka, our web designer. Hong Zhang, our web developer, and Key Choi. Nobody knows what Key does. We've divided a presentation into 3 parts. What we've done now with the data that's been provided, how we can improve what's already been created, and an exciting future-proof plan for our project. We used 3 different data sources. The Spring 2016 Merkle card transactions, we averaged these data into the number of transactions over every 5-minute period from 8 to 5 Monday through Friday in order to extrapolate how busy each coffee shop is during those periods. The Spring 2016 standard class times, because lots of transactions during a given period doesn't really mean a longer line, so we padded the transaction numbers during the breaks between classes. And the business hours for the coffee locations on campus, because not all the shops are open during work times. And we put all of that together and are using Google Charts to create all the charts that you see. So our solution to the best time for coffee was pretty easy. The best time is always right now. Users who come to our website can immediately see which coffee shop location has the shortest wait time or the longest for those who want to avoid work. And the site also allows users to receive twice daily notifications letting them know when they can expect the shortest or longest wait times at any given coffee shop. So here is Adam Truzinka to do a walkthrough of the website.
So this is our web-based mobile application, and it's actually functional if you want to go to JavaTime.online and check it out. So basically from the start, on the top, you see there's notifications that warn you any hazards or sales that are going on campus that are coffee related. And then we have the four coffee shops listed in order of the fastest, of the lowest waiting time or your fastest transaction time. And it's actually functional using the data that we were provided with. So these boxes, they reorder themselves based on the lowest wait time. And when you tap on one of the boxes, then it shows you the estimated waiting time for the next 20 minutes. If you have, in case you need time to walk somewhere, so you know what the trend is like. And there's a button to link you directly to Tap and Go if you want to order the coffee. And directions will take you directly to the map to give you directions on how to get to the coffee shop. And at the bottom, we have links for the more info about our app and an alert service which Hong is going to talk about in a second, and a scan button, which Key is going to talk about at the end of our presentation. So now I'm going to hand it off to Hong, who's going to talk about the alert system that we came up with.
This is a subscription service that we created for our users. Basically, the user just fill out a simple form with their name and their cell phone number and then the carrier, and also a few criteria they would like to have. Once they submit the form, these are just a few criteria we would like to have. Once it's submitted, then the service is subscribed, and the user will receive text alerts a few times every day, and you can also unsubscribe the service if you want to, just like in the past. So that's the next service that we provide. And next, Key is going to talk about the features of the service.
So
So when we're processing the data that was provided, we thought like, okay, it's good historical data to use, and we could come up with some predictions and we could chart that. But then the more we thought about it, we realized that we need more real-time data. We need additional data to really provide more accurate wait time predictions. So we thought like, okay, going forward, we should like maybe consider how many POS systems do they have, how many cash registers are they running at the same time, at one time, how many staff are working during whatever hours, during spring break are they reduced, during the summer are they reduced, or do they have a smaller wait staff? We need to incorporate, I think, more of the academic calendar information into the algorithm, and as much transaction information as possible. So right now we just have Rebel card transactions, but going forward we want to collect all like cash, credit card, as much of that as possible. But one actually really feasible and most accurate data that we could get is, I think, gate counts. So if we had a visual gate count system going into the store, so you could track the in and out, right? So how many people are coming in, how many people are going out. We set the number of seats available, so if you do some math, you say, okay, it has a seating capacity of 40, so at any given time, if there are 100 people in there, you say, well, maybe there's 60 people waiting for their drinks or ordering, right? So that would be a very busy time. So we thought that we could use something like this, and I know there's some controversy about videos and having that displayed. So this isn't actually UNLV. I tried to get that at the library, but they also poo-pooed my yeah, so this is like just top of people's heads, and they're like, no. So we have thought, and we are thinking about incorporating additional data sources for our algorithm, our Magic Wand solution. In addition to having, providing more accurate predictions for wait times, we thought, in Magic Wand Solutions, we're always thinking about the user and cutting edge technology, making it more convenient for people. And we, heard Pokemon mentioned a few times, and I think Pokemon introduced an augmented reality for the first time for many of the users. But one thing that Pokemon, the game, doesn't do is incorporate augmented reality trackers and markers. So Pokemon just basically uses GPS coordinates and plops Pokemon characters, and you go run to it and you interact with it. But augmented reality trackers and markers are like little symbols that you can put on objects and in buildings. And then if you have an augmented reality heads-up device, you can look at that object or marker, and then you can get information from that, right? It's like a visual overlay. So that's what we were thinking. Like, well, how do we incorporate augmented reality into our JavaTime solution? So let me do a quick demo here. So let's say, so in the future, in the very near future, everybody's going to have augmented reality built into their prescription glasses, sunglasses, and even contact lenses. So if I'm sitting at my desk and I have this canteen from, let's say, Coffee Bean, right? And so that's like their specific marker for Coffee Bean at the library. And let's say I'm looking at it. I'm just looking at my cup, right? I'm looking at it, and then like it should be faster than this, like in real time. Okay, it should be. Damn lighting conditions. Okay, I got something. All right, so I'm just looking at my cup, right? And I have information on there. So it's for the wait time, it's the Coffee Bean. It says 8 minutes, less than 8 minutes. And then the wait time is to go up with the arrow going up, right? So this is stuff that I don't have to look at my phone. This is just objects on my desk. Right, so I mean, it's very possible if it's Coffee Bean like sold reusable canteens and it was branded with these augmented reality trackers. This information, is just there when you're looking through your regular glasses. So let's say another scenario where, so let's say you're out and about, and and you're going by, let's see. So you're going by book and meeting, right? So you see a long line, and you're like, let's say the sign is over by book and meeting. So you're in a long line, and you're like, wow, that's a long line. I don't want to wait in that line. When's the next best time, right? So if you look here, it says best time of the day is 1:25 p.m. Right? It shows current time. It says estimated time now. Wait is 8 minutes, and the waiting time is going to go up. That squiggly chart on the bottom is actually the wait times for an 8 to 5 workday. So it's actually reflected there. So anyway, that's our augmented reality application interface to our JavaTime solution. So as a quick recap of our project, we completed a functioning, clean, responsive mobile website. It's highly visual, and we spent a lot of time on the marketing behind it, if you haven't noticed. So hopefully that'll get us some points. And then, we spent a lot of time thinking about future-proofing and preparing for the future with new technology. And so, with augmented reality, I think that's very doable in the very near future. And until we have robots, making our coffee and drones delivering our coffee, I think JavaTime solution is the best solution that's out there. So actually, you're gonna find this funny. The library is actually thinking about getting a robot to deliver coffee around the library. I'm not kidding. Thinking about that. So yeah, that's our presentation. Thank you.
So does it really send out up to the max number of alerts every time it's a reasonable wait time?
I can answer that quickly since I have the mic. So if you look at the form, it separates the day into two, so it's like 8 to noon and noon to 5. So you specify the number of times you want to be alerted for that, first half of the day and second half of the day. Right. So yeah, so if the wait time is pretty quick, earlier in the day you're gonna get those alerts earlier, and then.
Okay. I was curious whether it was a kind of like a spamming solution where it's constantly coming, or if it's a visualization where it shows you the minimums and you can plan your data.
Right. Yeah, we could send a link out in the text message as well with more of the trend information.
Yeah, both. That's what I'm sure.
Right.
So you're saying with the augmented reality, they don't have to go to the app, that'll be running in the background.
Right.
So they don't really have to click on anything.
Exactly.
They just scan that, and if it's a favorite coffee shop, they can just have it on their desk and scan it.
Exactly.
And that's all that happens.
Yep. You don't have to look at your phone. Yeah, in the future, you guys are going to be looking at your phones for information. It's going to be a heads-up display. So, all right. Any other questions?
All right. That's one solution. Thank you.